Hello, my name is Constantine A Murenin. I'm a BSD Unix system software engineer. And today I'm going to be talking about tips and tricks, cookies, location, and rewrite rules. So the talk is going to be about how you can use cookies, location directives, and rewrite directives within nginx. So first, a little bit about me. I'm a kernel and userland developer on a couple of BSD projects. I've been affiliated with OpenBSD, FreeBSD, DragonflyBSD, and NetBSD. And I'm also a big fan of short and concise links, and especially clicking on them. So what were some of the cool things that I did with nginx? So I created a couple of projects. One of them is mdoc.su. It's a deterministic URL shortener for BSD manual pages. And it's written completely within nginx.conf. It doesn't use any external utilities, and it doesn't use any JavaScript or any other higher-level languages. And then another one is bxr.su. It's called Super Users BSD Cross-Reference. It's a search engine that lets you search through the BSD source code of all the 4 BSDs that I'm a contributor of. And I've used nginx.conf, and I've also used OpenGrok for the search engine capability. And I'm also active on Stack Overflow. I help people avoid index.php on their websites and deal with stuff like URL encoding in the request and how to make sure that the upstream gets what it expects. So first of all, what's in the URL? So Tim Berners-Lee in 2008 he offered an article entitled "Cool URIs Don't Change." And I just use Google to find it right now, to tell you the truth. But I've also verified through the web archive whether the URL of this web page was actually the same when it was offered. So the earliest date that I found that this article was posted on the internet was, according to the web archive, was in 1999. So it's like 1 year after it was authored. And it actually exists, and it doesn't even redirect to anything else. It's like the exact same URL. And the article that appears here right now, it actually has a couple of addendums. So he mentions some of the extra things that came up over the years. But basically, it's like the same story, and it has the same URL. So if you go 20 years from now, and if you go to that URL, I'm kind of certainly reasonably confident that it's still going to be the same story, and it's still going to be working. So what are some of the other examples of cool URLs? So on nginx.org, there is actually also a special service implemented, /r, where you can basically have a direct access to the documentation for any of the directives that you may be looking to use in your configuration file. So for example, you can go to nginx.org/r/location, and it will automatically redirect you to the documentation for how to use the location directive. And same as for rewrite directive. And you can even use a $URI to see what the variable .URI, what it represents. And the same goes for request URI. And then the last URL, that's my website, so you can go to my website too. So on the previous slide, I've mentioned the URI and request URI. So how they actually different. So URI, it contains the URL decoded and rewritten so far. So for example, if you have a couple of rewrite directives in your configuration file, then the rewrite directives are going to directly affect what the URI variable holds. On the other hand, the request URI variable, it contains the original URI from the HTTP request. And another thing about it is that it's actually not URL decoded. So for example, if someone is trying to access // so they're trying to see if they can exploit some sort of vulnerability in your website to access the directory one level above what they're supposed to have access to, then you're not going to see the .. part in the URI, but you are going to see it in request URI. So for example, if you have your URI, it contains several slashes, then part of the thing that URI directive, part of the way that it's decoded is that those multiple slashes are going to be compacted into a single slash if multiple slashes appear simultaneously. So it's basically the difference between them. And the nice thing is that you can actually redirect between, you can look into request URI, and you can find if index.php, if it was mentioned in the request URI, and you can remove it, and you can issue the redirect to the user to remove the index.php. And that thing, it's only going to be, that directive, it's only going to be applicable if the actual request you write contain index.php. So if you do internal redirects, and for example, most of your website is handled by index.php, the URI variable, even if it contains index.php, that code is not going to affect it. I'm going to talk more about that a little bit later. What about web apps and web services? So when you talk about web apps and web services, usually people think that it's something that's written in PHP, Ruby, or Python, or for example, Lua, Perl, or JavaScript. And right now, as you probably are aware of, if you've been using nginx for a while, you can actually use Lua, Perl, and JavaScript if you compile certain modules for nginx. And then in that case, you can use Lua, Perl, and JavaScript right within the nginx configuration file. So the last one I mentioned is nginx.conf, because that service, one of the services that I've written, it's actually completely written, the whole service is written within nginx.conf. So why writing an app in nginx.conf is novel? Well, first of all, because it's a configuration language after all. I mean, how many of you have written like a complete app in just a configuration language? The other thing is that it doesn't support nested if statements. So you cannot say like if something equals something and then within that have another if statement. You can only have one if statement. You cannot have like if statements, like you can have multiple if statements on the same level, but they cannot be nested. And then also it has no support for multiple tests within a single if statement. So you cannot, there is no like and or within the if statement. You can only test like if a variable equals something else. You can use regular expressions, but you cannot use like anything else other than that. So is redirect is all the thing that I did in those services? So actually, that's not all that those services offer. So for example, you can go to the URLs presented here, and you can see that I can actually generate HTML pages right within nginx.conf. And those HTML pages, they're going to contain multiple links to basically such that you can provide one link to this service, and then it's going to contain multiple links to the stuff that you want to reference to. So for example, AIBS.4, it's one of the drivers that I wrote, and I originally wrote it for OpenBSD, but then I also ported it to Dragonfly BSD, NetBSD, and FreeBSD. So if I want to give a link, for example, like in my resume to this driver that I wrote, I can link to all the 4 different manual pages on all the 4 different BSD versions. I can provide a single link, and that single link is going to have all of those individual links within it. And the best part is all of it is handled within nginx.conf, so there is no extra overhead in doing this. So why is it better than going with PHP or doing some kind of other extra upstreams? So a good advantage is that it doesn't have, because there are no extra upstreams, you don't have to have any extra open files. So normally when you do proxying from downstream to upstream, then the server that is doing the proxying, it has to open the file for both the incoming connection and the outgoing connection. And then the upstream server, it also has to have an open file for the incoming connection. So that waits a lot of file descriptors, and if you're running kind of like at high capacity, then it's basically like an extra inefficiency that you can avoid. So then the question is like, how did I actually do it if there are like so many limitations within the configuration language itself, if I don't want to use any extra higher level language? So I did it by building state by looking at the URL one character at a time. And the way that you can do it is you can actually go from one location into another location, and you can issue internal redirects between those different locations. And the user is not going to be able to see how those internal redirects happening. So it's not going to involve any sort of round trip delay because of that, because all of those redirects are internal, and they're building basically the state. And then at each location, I keep the state, like once I get a certain state, once I know that something is happening, then I set the one of the independent variables that I have for that stuff that I'm testing. And then that variable is going to be holding that state that I took and I consumed. And then once the complete state is built, then all the variables are basically dumped back to the user. And this can result either in the user receiving HTML, which would be the case if the user, if one of those multiple links that I was talking about, or if it's just a single link, then it's going to result in just HTTP redirect being provided. And the status codes for multiple choices, there's actually HTML. HTTP standard. It actually has a specific status code, HTTP reply status code of 300, which means multiple choices. And what it lets the browsers and what it lets the crawlers know is that this URL, it actually contains it actually resolves to several different things. So that's actually what I do when I return HTML. And then in the case of HTTP redirects, then you can use HTTP permanent or temporary redirects, which would be like 301, 302, or 307, and some other codes. What is a manual page? I've been talking about this service for manual pages, but some of you may not know what a manual page is. So a manual page, it's a standard documentation in Unix systems. And you can basically, by looking at the manual pages, you can see what all the things that you can do in the Unix system. So manual page is identified by actually a tuple. Sometimes it's actually identified by a tuple because there's also architecture associated with it sometimes. So the first part of it is the name. So the name could be stat for looking at the file. And then the other thing that it's identified by is a section. So the section, it could be one for utilities. So for example, if you want to look the manual page for stat, the utility, meaning like the command line utility that you type in the command line, then you would look into the manual page for stat1. Or if you want to look at the system call, which would be the case if you're, for example, writing some sort of like C program where you have to make the system call, then you would look for the second section, which is a section for the system calls. So you would look in the manual page for stat2. And the standard notation within the Unix community to denote the section is with the parenthesis after the name of the thing that you're referring to. So the other thing that you may be wondering is what is actually mdoc? Why is service called mdoc.su? So mdoc, it's actually the language, graph language, which is the format that lets you describe the manual pages. So you can actually go to mdoc.su/f/graph.1, and you can see that doc, it's an option to graph utility. And it's documented that mdoc, that's a BSD style man page format. So you can look further into graph mdoc7. And the 7th section, that's a section for miscellaneous file formats. So you can go to mdoc.su/f/graph_mdoc.7, and then you can look at the manual page for how the format that describes manual pages, how it works. So how does mdoc.su actually work? So as I already mentioned, it has a lot of locations. So basically, I have location for each different operating system that it supports, and it supports FreeBSD, OpenBSD, NetBSD, and DragonflyBSD. There's like a separate location or several separate locations. And then within each of those locations, there's like one or more rewrite rules. And then with the rewrite rules, I'm building the state using regular expressions. I'm building the state. And basically, it represents a Turing machine. So we parse and save one state at a time, and then we go and continue until the end. And the whole thing is open source, so you can actually take a look at the whole configuration file, and you can also fork it on GitHub, which you should probably do if you're interested in it. So here are some more details about how it actually works. So one of the things that it does is it normalizes a case. So I decided against supporting arbitrary case. So like I don't like when people write OpenBSD with O being uppercase and BSD being lowercase. It's fine if they do it all lowercase, or it's fine if they do it with proper case, but I don't like it the other way. So what I do is in nginx, you can also make sure that the regular expressions they match like on any regardless of the case, but I do match based on case. So what I do is I issue an internal redirect if someone want to request /openbsd. If the request that comes in, it starts with /openbsd uppercase, then it basically gets redirected internally to /openbsd lowercase. Then the next thing that happens is that I expand the short version. So if you want to see the manual page for for a certain utility in OpenBSD that was appearing in a certain version, then you can basically just say /o45/stat.1, which would give you the stat.1 manual page as it was in OpenBSD 4.5. So what I do is I expand the short version, so that is another potential internal redirect that's going to be happening. Then what's happened next is that it consumes a version if specified and normalize BSD name into a single lowercase letter. So what I do is I basically put the x.y, I put it into the regular using the regular expressions. I put it in one of the variables. I'm using the named pattern matching of the POSIX compatible regular expression library, and that's a standard library for regular expressions that nginx is using. So, and then there's also a case of handling the case of multiple BSD being provided, where the page with HTML is generated. So are you ready for the code? So you should fork it and like it on GitHub, Bitbucket, or GitLab. So on all of those projects, it should be username cnst and mdoc.su. So I'm going to be going into the code in the next slide. So the whole file, it's relatively big. And each operating system, it actually has a different specification for the way that the sections, for the way, for example, that the versions are supported. So OpenBSD, it's relatively easy because it always has just 2 numbers for the version. So because of that, it's a pretty good example. So you can see that the first thing that we do is that we redirect from the uppercase to the lowercase. And then the second location, you can see that I have a couple of variables. So I have a variable that is going to be used as like the starting part, and then the variable that is going to be using like as an intermediate part. And you can see that basically I'm using the regular expressions, and I'm doing this matching, and I'm doing like a lot of those internal redirects. So some of them, they continue within the same location, and some of them, they're going to be jumping into a different location and is going to be processed further on in a different location. So you can see the question mark and then the less than BO greater than. That's the way that the named regular expressions work in POSIX compatible regular expressions. So what it does is that if that thing matches, then the BO variable is going to be set, and it's going to be set to that thing that's matching. So then later on, I can test what that thing was matching. So you can see that I'm already testing here if B variable was previously set. So I thought that I could actually give you the demo of how it works. So this is how it looks. And basically, if you click on any of the links, then it's going to immediately redirect to one of those things that are specified. So you can see I clicked on the NetBSD link, and it opened me the page for NetBSD. But of course, the best part is multiple redirects. So this is the multiple choices pages that I was talking about. So you can see that it redirects to the OpenBSD manual page. And the best part, of course, is that like many different notations can be supported. So this is just a dash notation, which means that it's going to be provided all the choices for this manual page for all the systems that you may want to look at. So that would be good if, for example, if you want to give a link to the manual page for stat. So you want to give a link to someone so that they can see what is the difference between the stat system call in all the different systems, in all the 4 systems that are supported. But if, for example, you know that certain system it's only supported in 2 of the operating systems at stake, then you can do that. So for example, you can do the F, comma, D to see the OpenBSD and Dragonfly BSD manual page for if config. Cool. So let's go back to the talk. Can't find my pointer. So the talk is titled Tips and Tricks. Here are some additional tricks and tips that you can use on your own website. So one of the things that you can do is Google site verification. You can actually do Google site verification without downloading any certain file from Google Webmaster Tools. So a couple of years ago, I went to Google Webmaster Tools and I wanted to have my site verified. And they, what they said is that I have to actually download an HTML file from their website. And there's like no way to actually see it because when they serve the file, they serve it with a content disposition attachment. So what the browser does is that it asks you to save that file. It doesn't actually let you look at that file. So that may be a problem if you're on something like an iPad, where, well, last time I checked, it wasn't letting you save the files. Maybe that's changed. But basically, what you can do is you can do this Google site verification directly within nginx without using any external files. So one of the things that they do is that they require basically the string Google site verification and then followed by the name of the file. So the trick is that the name of the file, it has to not have a slash in front of it. So what we have to do is we have to remove the slash. So of course, we could like copy paste it twice to use it both in the location and in the return directive. But what could you do? What you could use instead is you could remember that the URI directive, it simply handles the state of how the URI it was rewritten so far. So what we could do is we could remove the slash from the URI with the rewrite directive, and then we can supply that URI as a return. So this thing is going to return the name of the file without the slash in front of it. So and the other thing is this is an example of how you would remove index.php from your website. So remember I mentioned the difference between URI and request URI. So what this thing does is that it removes index.php and it issues a 301 redirect to the user only if index.php was appearing within the request URI. So the way that index directive works is that it's actually gonna set the URI to index.php. So if in this code, if instead I would have been testing just regular URI, then it would result in an infinite redirect loop, because every time there's no index.php specified by the user, it's going to be automatically assumed, if it's a directory, it's going to be automatically assumed to be index.php by nginx. And index.php is going to be added into the URI variable. So if I would have been testing URI variable here, then it would have resulted in an infinite loop. So that's why you want to be testing, you want to know the difference between a request URI and URI. And in this instance, you want to be testing request URI. So the other thing that I mentioned, the other service that I'm running is based on OpenGrok. So for those of you not familiar with OpenGrok, OpenGrok is listed as being the fast and usable source code engine, source code search and cross-reference engine. And it is written in Java. And as with many things written in Java, it's heavily based on cookies. And I personally like to refer to applications that don't work in multiple windows, that are not being able to be used in multiple windows simultaneously as legacy applications, because it's just very inconvenient that you open several different windows, and then basically those windows, they kind of interact with each other in the way that you didn't expect it to. So a brief introduction to cookies. So cookies, they're simply headers in HTTP. So the cookie header, it's sent by requests in the request by the client to the server. And then the set cookie header, it's sent in replies by the server to the client. So it could be the upstream that would be sending the set cookie header. So OpenGrok, by default, is going to be sending the set cookie header right away pretty much all the time. And the best thing is that you can set up clear cookies as well as make decisions based on cookies right within nginx.conf. Like in any nginx version, you don't have to have like JavaScript support or Lua support or Pro support. So how does OpenGrok actually handle cookies? So the way that it works in OpenGrok, the way that OpenGrok is implemented is that query string, which is the args variable or query string variable, it actually overwrites the cookies within OpenGrok. And then cookies are actually being reset based on args. So if you're using the regular OpenGrok and if you make it a search request, then you have to specify which project you want to search in. And once you specify which project you want to search in, then that project is going to be set into a cookie. So for example, if you have multiple different windows open and you search in several different projects, then that's going to create basically the inconsistency and the race condition that one window is going to be, you're going to be searching one project, and then the other window you're going to be searching another project. But because of this cookie thing in OpenGrok and the default way that OpenGrok works, then it's not going to work correctly. And it also makes sharing URLs difficult and caching as well. So for example, if you want to, I personally, when I share URLs, I want to make sure that I'm sharing like the shortest possible URL. So if it has a lot of random characters in it, and those random characters, they don't denote any sort of ID or anything like that, then I usually like to remove those to make sure that people just don't copy-paste URLs that are just unnecessarily long. So, and this approach, it makes it difficult if cookies are involved, because there could be a cookie set for the search request, and then I'm sharing with this URL with someone else, and they don't have that cookie set. So then the thing is not going to be working. So because of that, I really didn't like that, not just because that it's ruins the caching, because cookies are basically set on every single page in OpenGrok, but it also ruins the sharing of URLs. So I wanted to get rid of the cookies, and I did that. I did some prototype within OpenGrok itself, but then I found that it was much easier to just do that within nginx itself, so that I don't actually require any sort of modifications to OpenGrok at all. So the file that I have, the configuration file that I have for bxr.su, it's actually going to work with just the default OpenGrok installation, even though OpenGrok requires cookies, and my site, it doesn't have any cookies at all. So the way that I did, in bxr.su to ignore cookies is that you have to specify several directives within nginx. You have, first of all, to reset the cookie header that was sent by the client. So I use the directive proxy set header cookie, just question, like the double quotes. And then the other thing is that you have to make sure that the set cookie header is ignored when it's provided by the upstream. So I use a directive called proxy hide header and proxy ignore headers. And you have to use both, because I'm heavily using the caching in my service to cache every single request that comes in. The reply to every single request from the upstream that comes out. And I wanted to make sure that that set cookie headers that are being set by the upstream, they're not going to influence my caching. So because of that, you have to use both. You have to use one of the directives to make sure that the things can still be cached, even though it did have set cookie. And the other thing you use to actually remove the set cookie header. So this is another example of the difference between the internal and the external redirects. So what I wanted to make sure is to remove the extra /xref that is used in OpenGrok to provide the cross-reference for the projects. So because bxr.su, because it only supports 4 different projects, then there is not any ambiguity in which projects, what are going to be the project names versus what are going to be like the other URLs that are going to be used to denote any sort of other function. So because of that, what this code does is it actually redirects. If the user tries to access xref as a starting URL in the service, then it will automatically remove it. So using this code, I was actually able to rewrite all the URLs and effectively remove the xref from within all the pages that I used to that I used on the service to generate stuff. So some other optimizations that we did is if the 502 error comes from the upstream, I can provide alternative links to alternative services. So because this is a community project that I'm supporting, I don't really care if I give links to my competitors, so to speak. So if my upstream is down, then you could use basically the redirects, the stuff that I mentioned about the first service that I implemented, to provide the links to other services that could be found useful by the user. So I've faced some issue with that, is because OpenGrok, when you try to reinstall OpenGrok in Tomcat, it actually returns 404 errors whilst it's being reloaded. So it doesn't actually work properly, so I'm going to be fixing that sometime. And the other thing is that I also provide in this service bxr.su, I also do the same thing as I did with mdoc.su. So if you want to give just a link to FreeBSD to some certain file within FreeBSD, you don't have to have like really long URLs. You can just type /f/current/current_cctl.c or something like that. So with this, there's some time for questions. Do you guys have any questions?
In the first example, what's the return 400 code for at the end of the configuration block?
What again?
In the first example, what's the return 400 return for or return 410 at the very end of the configuration block for?
Was it in this example, or which example? Was it the mdoc or bxr example? Do you know?
The mdoc example.
This one?
Yes.
So what is the question again?
What's the last line, the return for or the return for 104? Like.
Oh, so basically the idea here is that those rewrite rules are supposed to redirect into other locations. And then in some cases, it could be that, for example, someone maybe try to access /o and then maybe D. So OD is not something, no, OD is actually supported. So maybe someone has tried to access O and then A. So A is not supported, and it's not a valid request. So if you try to request /OA, then the return 404, that's the one that's going to be handling that request. So it's done to make sure that, like, at the end of the day, because if none of those rewrite rules, if they don't redirect anywhere, then what's going to be happening is that you're going to be able to access a file system. So if we don't use that return 410 here, then potentially an attacker might be able to bypass like your idea of like what files are going to be accessible, and may be able to access certain files on the file system that you thought were inaccessible. That's a great question, by the way. Thank you.
Thanks.
So on the nginx documentation, it says the if is evil. And I was wondering, you use if pretty liberally.
Right.
Is there any performance decreases, increases, or any kind of cons or pros to that?
So it's actually a pretty common question. Like every time I use any sort of if directives, especially like on Stack Overflow, people always like to link to that article called "Ifs Are Evil" or "If is Evil" or something like that. And what it describes is that it, like, in certain cases, it may return results that you do not expect. But the other thing that it describes is that every time you use it, it's going to be returning the exact same, it's basically, it's all reproducible. So it's all deterministic. So if it's actually working, then it's going to be working like 100% of the time. So if it doesn't work, it's not going to be working. But if it actually works, then it's going to be working like all the time. So what it actually describes is that you cannot, when you use an if directives with certain other directives, then you may experience unexpected results. But if directive, it's implemented within the rewrite module. So it's totally safe. It's 100% safe to use if directive with any other directives within the rewrite module. And all of the directives that I'm using, including return and rewrite, they're all part of the rewrite module. So that article, if is evil, it doesn't apply here at all.
Thank you.
But thank you for the question.
Thanks.
Thanks.
Going back to the same example, is there, or how do we figure out the order of the rewrite calls? I know that the ones which end with last are supposed to sit control and go back in the loop of resolving the URI, but for those who are not, is there any order or is deterministic?
Yes, it's completely deterministic, so it's all processed sequentially. So each rewrite directive, it all processed like from the first one that appears to the next one. So the order matters, the order of the rewrite directives matters. And as you can see, like some of them, they're going to be matching and then they're basically going to be redirecting to like other stuff, or some of them are going to be redirecting to some other locations. So for example, the last one that I have here, I think it's going to be redirecting to one of those HTML pages. So it's going to be redirecting to that HTML multiple choice pages. But all the other ones, the ones that end with redirect, that's going to be providing the HTTP 302 redirect right away. But the other ones, the ones that are saying last, that means that it's basically going to be going into another location. It's going to start searching another location. Thank you for the question. Do you have any other questions or to answer?
Hi, is there a way to debug the rewrites?
So that's a pretty good question. So the way that I found, usually you wanna debug is regular expressions, because sometimes certain things, especially if you're going kind of like hairy like this, you may want to make sure that like the regular expressions work the way that you expect it to work. So nginx, the library that nginx is using in order to support regular expressions in all nginx versions, it's actually called PCRE, parallel compatible regular expressions, and the library is actually written in C, and it's available in all Unix distributions. And what you can do is you can type on the command line, you can type PCRE_test, and you can provide the regular expression, and then you can also provide the strings that you want to match it against, and then it's going to show you the variables that, like for example, the captures, what captures were matched, and what stuff was matched and what wasn't matched. So.
That may be it.
Cool. Well, thank you very much for attending my talk.